Okay, so everyone's okay with number 79. So I'll make a note here. So this has 6, this graph has 6 x-intercepts using the derivative. But again, the other option, if you didn't want to find the derivative, that's fine too. Graph the original function, it had 6 turning points between 0 and 4. Okay, so other questions on this page?
Can we do 82?
82, yes. So I'm going to clear this out. Let's look at number 82. Okay, so 82, between 0 and 4, of the following, which is the greatest value of x, such that the left expression is greater than or equal to the right expression? Okay, so here, I am going to, if I want to find the greatest, that's another word for the maximum value. So if you want to maximize something, you want to take the derivative. So I'm going to maximize the left integral and maximize the right integral. So what I'm going to do here is I'm going to take the derivative of the left integral, and I'm also going to take the derivative of the right integral. So this is fundamental theorem of calculus, which I would be shocked if it's not at least one part of your free response question. So when you take the derivative of an integral, you're undoing it. You're getting back to where you started. So if you have x, you plug it into the dummy variable. The dummy variable here is t. So the t has no effect on your answer. You're just taking the x and you're plugging it in for t. So you get x squared minus 2x. If you have a constant on the bottom, you'll end up having to take the derivative of the constant, and it does not affect your derivative. So I'm going to say x squared minus 2x. Okay, so that needs to be greater than or equal to x. Sorry, let's see. Which is the greatest value? Okay. So for this other one, I'm going to say greater than or equal to x. I don't know when this equals 0. I'm trying to think how that's going to help me here. X cubed over 3 minus x squared. This is a tricky one. Use your calculator. Oh, let me do something on my calculator here. If I plug in the numbers, I do 1.35. Okay. You know what? When I'm doing the grade, because when you're doing the maximum, you have to set it equal to 0. That doesn't really make sense for this one. So I think I'm just going to have to do trial and error by finding, without taking the derivative, just find both of the integrals and figure out using my calculator by trial and error which is the biggest number that would make the expression true. So eventually I thought this was a maximization problem or optimization, but there's no way I can set this equal to 0. So that's the second step for optimization. Find the derivative and you set it equal to 0. But that's not going to apply here because we're comparing two expressions. So what I'm going to do instead is I'm going to find the left integral and the right integral. So backtrack to the beginning, I apologize. So when I integrate from 0 to x, it's going to look like this. It's going to be, my left side is going to look like this from 0 to x. When I integrate it, it's going to be t cubed over 3 minus t squared. And this is going to give me x cubed over 3 minus x squared. And this needs to be greater than, because when you plug in 0, it just goes away. So you don't even have to worry about plugging in 0. So this needs to be greater than or equal to. Greater than or equal to. So when I integrate the right side, when I integrate t, it's going to be t squared over 2. We're going from 2 to x. So when you plug in x here, you're going to get x squared over 2 minus 2 squared over 2. So 2 squared is 4. 4 divided by 2 is just 2. So that's what I would set up. And at this point now, all I'd have to do is start plugging in the answers and see which is the biggest number. The nice thing is, once it doesn't work for 1, it's not going to work for anything bigger than that. So I'm going to try 1.35. I'm going to plug in 1.35 into the blue and the red. So I'm going to do 1.35 cubed, divide that by 3, minus 1.35 squared. It gives me a number, negative 1.002375. Now I'm going to plug in 1.35 into the red. So 1.35 squared divided by 2 minus 2. It gives me a number that's smaller. So I know 1.35 works. So let's try 1.38 because I'm trying to find the greatest value for x. So it works for 1.35. Let's see if we can find a bigger one. So now I'm going to plug in 1.38 into the blue. So 1.38 cubed divided by 3 minus 1.38 squared. It gives me a number, and then when I plug it into the other side, 1.38 squared divided by 2 minus 2. So it still gives me when I plug in 1.38 for x, the blue is still bigger than the red. So let's see if it works for 1.41. So 1.41, when I cube that, divided by 3 minus 1.41 squared. And then I'm going to do 1.41 squared divided by 2, and then minus 2. So the number I get in blue is no longer bigger. It's negative 1.05, where the red number is negative 1.00. So that means if it doesn't work for 1.41, it's not going to work for anything bigger than 1.41. So my answer here is going to be 1.38 is the biggest number that would make this inequality true when you plug it in for x. Kind of seems like a dumb problem to me because you're having to use the answers and just work backwards, but I guess that's what you have to do for this one. So is that okay for number 82?
Yeah, thank you.
Okay. Mm-hmm.
Can you do 83?
Yeah. So before I start 83, just know that usually if it says the greatest value, you would have to take the derivative and set it equal to 0. But for this one, there's no way to set it equal to 0. So that's the reason I didn't do that. Or I started to, but realized I was stuck. And that's okay. Once in a while, you start a problem, you see that it's not working, and then you have to try something else. That's part of calculus. Okay, so let's look at 83. So 83 has a differential equation, a diff EQ. Hopefully you guys have been able to watch some of the videos. I know one of the videos had to do with differential equations on the links I sent you. So College Board's creating a bunch of like videos knowing that students aren't in class. So they've never done that before. So it's kind of a cool thing where the people that are like high up in terms of like even writing the AP exam, some of them are part of that process. So they're leading videos to help with what you guys need. So that would be really good review to watch those. So I think the last couple of posts I put on Google Classroom, I included a couple links for those. So if you want to watch them live, the BC ones start at 6 a.m., but you don't have to watch them live. I would not be getting up at 6 a.m. I'm guessing you wouldn't either. So just know that is a great option to be able to watch, to go back and review some of these topics again. Okay, so 83. So we have a differential equation. So we want to separate the variables and take the integral of both sides. So on 83, let me see if I can expand this any. That's nice. I like having all the space. So on 83, this is another one I kind of expect you guys are gonna see in May. Differential equations are popular problems, especially for free response. Okay, so here I'm gonna do dy. I'm gonna divide both sides by y to get all the y's on the same side. And then I'm gonna multiply both sides by dx. So the left side, the dx goes away. And then I had 1 plus ln of x left over, so I'm going to times that by dx. So now that I've separated the variables, all the y's are on one side, everything else is on the other side. At this point now is where I would take the integral of both sides, because that's how you undo a differential equation. Once the variables are the same, you take the integral of both sides. dy over y is the same as 1 over y times dy. What's the integral of 1 over y? Someone speak up with their mic on. Integral of 1 over y.
Natural log, absolute value y.
Good, perfect. Natural log of absolute value of y. I heard a couple people saying it there, so thank you. So then I'm going to integrate the other side. So the integral of 1 is just x. If you want to take the integral of ln of x, you could have this memorized, but there's a good chance you don't. So I'm going to show you how to find the integral of ln of x if you don't have it memorized. So doing a little scratch work off to the side. If you want to find the integral of ln of x dx, I'm going to do integration by parts. So my u is going to be ln of x. My dv is whatever is left over. So in this case, all that's left over is dx. You may have forgotten that this is allowed for integration by parts. You can just let dv equal dx. So du is going to be 1 over x. And then v is just going to be x when you take the integral of both sides. So I'm going to use ultraviolet voodoo. So it's uv minus the integral of v du. So when you do v times du, x times 1 over x is just 1. I should have a dx up here. So it's just 1 dx, which is the same as dx. So that's going to give me x ln x minus x. So if you have this memorized, that would save you some valuable seconds, but it's one that doesn't show up that often. So that's why I'm guessing you probably don't have this memorized. So if you forget, you can always do integration by parts to find the integral of natural log of x. Okay, so that means I'm going to write this as plus. When we integrated ln of x, it was just x. You don't need the parentheses here, but plus x ln x minus x. And then I'm going to do a plus c. So when I simplify this, this is going to be ln of absolute value of y equals, when I combine these two, x minus x just goes away. So it's just x ln of x plus c. Oh, this is nice. Everything's working well. There's no lag. I'm assuming if no one's complaining that my audio is okay. All right, so here to get y by itself, I'm going to take base e, this invisible e right here, and raise it to whatever's on the other side of the equation. So e to the x ln of x plus c. So all of this is part of the exponent. And this is going to look like this. It's e to the x ln of x times e to the c. Because if you multiply common bases, you're just adding the exponents, but we're doing that step backwards. So now I'm going to say absolute value of y equals, someone speak up again. What's another way to write e to the c?
C.
C. A number raised to a number is still a number. So E is a number, C represents a number. So that's just going to be some constant. E to the x ln of x. Okay, so now I have y equals plus or minus, it becomes plus or minus c, which is still c. So that's how you get rid of the absolute value. Just make the other side plus or minus, but plus or minus c doesn't change. It's still a c. Okay, so now there should be an initial condition given to solve for c. So it says y equals 1 when x equals 1. So to solve for c, I am going to plug in 1 for y when x is 1. So when x is 1, it's just 1 times ln of 1, which is ln of 1. Ln of 1, hopefully everyone knows that's 0. So e to the 0 is just 1. So c times 1 is c, so c equals 1. So I'm going to take 1 and I'm going to plug it back in here. So that's going to give me my answer, I believe. So y equals 1 times e to the x ln x. And the problem is saying y equals. So you don't have to include the y equals. It's just e to the x ln x, which is letter E. So again, I don't know for sure what's going to be on there, but this is one of those that shows up very often on free response questions, as you're going to see as we start going through them next week. I mentioned in the last post on Google Classroom, over the years, the free response questions have been very predictable. Like they use the same types of questions year after year, just changing the numbers and maybe a couple little twists here and there, but for the most part, it's the same types of problems. It's even the same numbers. Like number 6 is always going to be a Taylor series. Number 1 is always going to be a rate in, rate out problem. Number 3 is always going to be analyzing a graph using integrals. So it's like there's a lot of things that are predictable. I'm not sure exactly what that's going to look like this year, but I would anticipate that there's going to be the problems that you're going to see, for the majority of them at least, will be similar to old free response questions. But we will know for sure on the day of the test, but that's my best guess right now. And this is one of the concepts. It's even though it's a multiple choice question, it also often shows up on free response. All right, so any questions on 83? Or other questions on this page?
85.
85, let's look at 85. So I'm going to clear this out. Ooh, I can already tell just from first glance, this is a good problem. Because this is something you have to know the difference between average rate of change and average value. Those are two very different things. Okay, so average rate of change on a graph, that's the slope of a secant line. So I'm actually going to clear this out because I want to use this space, but just a quick review. If you want to find the average rate of change from, like let's say you're going from 1 to 3. You have a graph that looks like this. If you want to find the average rate of change from 1 to 3, that's just going to be the slope of a secant line. If you guys remember, a secant line is a line that intersects a graph at 2 points. So if you can find the slope of this line, that represents the average rate of change. The average value is the integral over the interval. So it's like if you find, we did like a temperature example earlier in the year, was one of the first ones we did. So you would find the total temperature over like all the temperature over a certain period of time, and you divide by the interval from like hour 2 to hour 7 when you're taking the temperature readings. Okay, so I'm going to clear this out. I just want to make sure. So this is what the red line goes with average rate of change when you find the slope of the red line. So that's y2 minus y1 over x2 minus x1. So please don't confuse that with average value. Okay, so right here it says the average rate of change. Which of the following must be true? So I'm going to say true or false for each one. So for 1, if I want to find the average rate of change, I'm finding the slope of a secant line. So it's going to be y2 minus y1 over x2 minus x1. So using this and using this. So this is going to give me 5 over 2. So this one right here would be true. So let's go to number 2. The average value of f is 9/2. So to find the average value, you need the integral of the function over the interval. But we don't know what the original function is. So how would I know? So I'm going to say this one's false because we don't know what the original function is. So how can you find integral of a function over an interval? I know the interval is 2 from 1 to 3, but I can't take the integral of a function if I don't have a function. So 2 would be not enough information. So I'm going to write that, not enough info. And then f of x not given. If it said what f of x equals, then I could take the integral from 1 to 3 and then divide that by the interval, which is 2, but we don't know what f of x equals. Okay, so then for 3, we're taking the average value of the derivative. So this is actually going to be the same as the average rate of change. So this one here, I think we had a problem like this first semester. Like I think it was like one problem out of the textbook that you had to make this connection where I wish we would have done more like this, but the average value of the derivative is the same as the average rate of change. So we already said on number 1 that this is true. So this equals, so average value equals average rate of change. If the average value, I'm sorry, I need to underline more. This is very important. The average value of the derivative. So if I just said average value, that would not be correct. So the average value of the derivative equals the average rate of change. Because it's like you're taking the, let me think if I can do this. Don't write this down because I have to think this through. But if you were to take the integral of a function, like in this case from 1 to 3, divide by the interval, be 3 minus 1. This would be the average value. Then if you take the derivative of this, so you're taking the derivative of the average value. But here it's saying take the average value of the derivative. So what does this give you? So this would be 1/2. So again, don't write this down. I haven't thought this through. I'm just seeing if this works. I don't think so, because how do you take the derivative? So f of x. Kind of just playing around on here now. I'd probably have to do an example to show this better, because I'm taking the integral of the derivative, not the derivative of the average value. So the average value of the derivative. Wait, I might have an idea. Let me try one more thing here, just playing around. Okay, so the average value of the derivative So from 1 to 3 over 3 minus 1. This is going to equal, oh, I think it's going to work. Okay, so f of 3 minus f of 1 over 3 minus 1. And isn't that the same as the rate of change? Okay, so that was what I had originally had in mind, but I set it up incorrectly the first time. So if you're going from 1 to 3, so you're taking the average value of the derivative. You take the integral of the derivative from 1 to 3 divided by the interval, so 3 minus 1. So you can see when you do this, it gets you back to the original function when you take the antiderivative of the derivative. So you're just doing f of 3 minus f of 1, which is over 3 minus 1, which is the same as the slope of a secant line. So hopefully that made part 3, you can make a little more sense of it now. All right, so other questions on this page. You guys are staying with me. I see some people that look attentive. There's others that seem like they're distracted. So thank you, those of you. Yeah.
You looking at me, right, Mr. Morrison?
I haven't gotten to you yet, Chris. I'm just scrolling through everybody. What was that question again, Jacob?
Is 88 on that page?
88, let me check. No, not yet. I'll do that. I'll try to remember to do that one first, though, when we go to the next page. Okay, so anything else on 79 through 86? You guys are okay with number 86? I could definitely see a partial fraction problem being on there since that's a BC topic. And I think they're going to focus on BC topics, but that's a guess. A lot of what I'm telling you is just based on my experience and what I've seen in the past. I obviously don't know for sure what's going to be on there, but trying to anticipate. I've usually had success over the years anticipating an idea of what they're going to put on there. So hopefully that'll continue. But I could see something like a partial fraction problem definitely being on there. So anything else on 79 through 86? Yeah, and another thing I'm confident they're going to do is try to tie different concepts together into so it says 2 free response questions. Each free response question is going to have multiple parts, and you're going to see that over the next few weeks as we practice old problems. Okay, so last call, 79 through 86. Okay, going to the last page here. I told you could skip number 90. We don't have to know Hooke's law anymore. That was an old concept. So you said 88. So let's look at 88. So when you see instantaneous rate of change, I need someone to speak up again with your mic on. What do you do when you see instantaneous rate of change? You can just give me one word. Derivative. So instantaneous rate of change means that I am taking the derivative. So right here, I am going to take the derivative of my function. And my function is the integral from 0 to x squared of sine of t dt. So this is extended fundamental theorem of calculus because x squared is a function whose derivative does not equal 1. So you have to times by the derivative of x squared, which is 2x. So what we're going to do here, when you're taking the derivative of the antiderivative, it gets you back to where you started. So you keep it as sine, but instead of t, you're going to substitute x squared. So it'd be a good idea to go back in your 5.4 notes. We did this the long way. So this will help you make sense of why it's just sine x squared, but then and also why you have to multiply by the derivative of x squared, which is 2x. When you have a constant like 0 as the lower limit of integration, you end up taking the derivative of the constant, which is just 0. So that just goes away. So that's what I'm going to get for the first part. And then for the second part, let me use I'll use red. I want to find the average. I'm going to use red. Let me undo that. Okay, the average rate of change. So what that's going to be y2 minus y1 over x2 minus x1. So I'm going to do a little scratch work at the top here. Oh, actually, I'm just going to write it out like this. It's going to be f. What happened? That's so weird. I didn't know I could do that. Sorry. Let me close this out. Okay. So this is going to equal y2 minus y1. So this is my average rate of change, y2 minus y1 over x2 minus x1. I'm going to say, where does it equal? So these two things have to equal each other. Okay, so if you want to find f of square root of pi, now I'm going to do my scratch work. Wherever you have room, if you want to do f of square root of pi, I'll do it up here at the top. This is going to be the integral from 0 to square root of pi squared. So the square root of pi is my x, so it's from 0 to x squared of sine of t dt. So the integral of sine is negative cosine. If you want to pull out the negative, you can. And we're going from 0. When you square the square root of pi, it's just pi. So this is going to equal cosine of pi minus cosine of 0. So cosine of pi is negative 1. Cosine of 0 is 1. So negative 1 minus 1 is negative 2. Let me check that again. So negative, but then you're saying the opposite of that because there's a negative in the front. So the opposite of negative 2 is going to be positive 2. So we just said that f of square root of pi is just 2. If you want to find f of 0, so I'll put a comma here. It's going to be f of 0. This one's easy because you're taking the integral from 0 to 0 squared, which is 0 to 0. So I need someone's mic turned on again.
0.
Let's see. It's just 0. The integral from a number to the same number is always 0. So it doesn't even matter what the rest is. This just equals 0. It's 2 minus 0 over square root of pi minus 0. This is a good problem. It covers a lot of stuff. Okay, so now I am going to write this as 2x sine of x squared equals 2 over square root of pi and then I'm going to write this as 2x sine of x squared. I'm going to subtract 2 over square root of pi from both sides. and set this equal to 0. So what I'm going to have you do now for the extra credit is graph this on your calculator, but change the 0 to a y, and then take a picture of your graph.
Wait, what did you cut out?
So you're going to put this on your graphing calculator, and then take a picture of your graph, and then you can upload that on Classroom for the April 6th extra credit. All right, I'm going to do that on my calculator. So I'm graphing y equals 2x sine x squared minus 2 divided by square root of pi. Gonna hit graph. I'm gonna change my window to be, let's see, for my window, I'm gonna go from 0 to square root of pi. So from 0 to square root of pi. So my x min is 0, my x max is square root of pi. So I can see here, it says at how many points. So hopefully, if you can see my calculator here, you can see from 0 to square root of pi, it has 2 intersection points. So the question is asking how many times does the average rate of change equal the instantaneous rate of change? So hopefully you can see it on your graphing calculator too. So you can see that it has 2 x-intercepts, so that we were able to solve this equation on our calculator when y equals 0 is a definition of an x-intercept. So change the 0 to y, but it's going to represent the values of x that makes y 0. And so this tells us that we have two intersection points. So 2 x-intercepts. Means that we have two points in time where the instantaneous rate of change is equal to the average rate of change. So hopefully everyone had a chance to do that. You got a picture, you submitted it on Google Classroom. So any questions on number 88? I'll leave that up a little longer. I know some of you might be distracted trying to get that extra credit in. And while I do that, let me see here. And then if I can get, let's see. So right now, if Nathan, Mikkel, Kaylee, Diego, Connor, Alexis, if you could turn your cameras on, that would be helpful.
I can't get mine to work, but I'm here.
Okay, thank you. All right, so any questions on number 88? Everyone hopefully was able to see that there were two x-intercepts. So again, that was a good problem because it forces you to make, this is a big idea of the AP test, is you have to make connections. So here you're making a connection between the instantaneous rate of change and the average rate of change and showing that they're the same at two different points, two different values for t. Okay, so other questions on this page?
Can you do 89?
Yeah, let's look at 89. So I'm going to clear this out if there's no questions on 88. Okay, so looking at 88. Let's see here, or sorry, 89. So 89, it says if f is the antiderivative, so we're going to take the integral of this such that f of 1 equals 0. We want to figure out what f of 4 equals. Okay, so right here, I'm going to take the integral of this from 1 to 4. So I'm going to clear off my screen first. Okay, so to clear out my screen, okay, so here I'm going to write it at the top. So I have final value or future value equals starting value. This also has to do with fundamental theorem of calculus because there are multiple parts to fundamental theorem of calculus. So final value equals starting value plus net change. Another word for net change is accumulation, how much of something occurred over time. So plus net change. So these show up all the time on free response questions. So again, you're going to see that over the next few weeks. So we still have a little over a month. So that's, I think we're doing well on, or like we're on schedule, but we do need to really hit multiple choice this week to get to where we need to be. Okay, so the final value is going to be f of 4. So I'm going to say f of 4 is going to equal the starting value. So we're starting at 1. So it's going to be f of 1 plus the net change. So the net change is going to be how much it changed from 1 to 4. So that function is going to be x squared over 1 plus x to the 5th dx. So this, what this integral tells you, the integral from 1 to 4, it tells you how much the particle or whatever, it doesn't say that it's a particle, but how much something changed from x equals 1 to x equals 4. F of 1 is where we're starting at. So if you could, well, f of 4 is going to equal, we know that f of 1 is just 0, so you don't even have to add 0. That's not going to change anything, but it's going to be the integral from 1 to 4 of x squared over 1 plus x to the 5th dx. So if you could plug this into your calculator, that should give you your answer. I'll do that now. So we have a little extra time today, so that's good. I'm not rushed since you guys haven't finished 1993 yet, so we're not going to jump into that. I was hoping to be able to answer some extra credit problems, but I ended up making it due later because, like I said, I couldn't find the book anywhere. So I hope you guys are able to work together outside of class. You're able to connect, whether it's through Zoom or FaceTime or Skype or anything else. But it's important that you are working together going through the AP review, because I would think that your primary motivation right now is getting college credit for the work you've already done this year. So hopefully that's your main motivation. And the grades should be also motivating, but that should be secondary. Okay, so I'm doing math 9 from 1 to 4. I'm using an older calculator. I also forgot to grab Dora. So x squared, I have to remember how to do it on this calculator. 1 plus x to the 5th, comma. And it gives me 0.376. So that looks like letter D. So we're starting at f of 1, and then we're integrating from 1 to 4 to figure out how much it changed from x equals 1 to x equals 4 to get our final value, f of 4. So again, you're going to see a lot of problems like this one coming up soon. So any questions on 89? Everybody's good. Okay, other questions on, or did we do all of them on this page? Or any other questions?
$87.
87. Let's look at 87. Oops. Oh yeah, there's 87 here. Okay. Make sure I can see everything. All right, so 87. Okay, and also before I start 87, I'm hoping everyone is okay with logging into albert.io. So I'm guessing most or all of you have done that before. So you guys are able to see find the 2 exams under assessments. I think if you go to assignments, it's not the, I think there is an assignment posted, but that's not till later in the month. So make sure you click, I believe you have to click on assessments, and you should see 2 BC exams there. So that's what's going to be due on Friday. So before I start 87, just while I'm thinking about it, any questions on the Albert.io stuff? Hope everyone had a chance to access those 2 exams and you found them okay?
Are they extra credit?
Yeah, so the Albert.io, you can get up to 10,000 extra credit test points. But I am looking at a few factors, so if I can tell if you're putting in effort. So if it looks like you're just like putting a whole bunch of answers in, then I definitely will take that into account. You can get up to 10,000 extra credit test points from that.
Can I see your work?
I don't have to see your work. I can tell, there's a few ways I can tell how much time you are, or how much effort and time you're putting into it. But again, you're, like I said earlier, your main motivation should be getting the practice. That's what's going to help you for the AP test. So you shouldn't need me to have to motivate you. All right, so 87. So this was a cross-section problem. So I'm going to draw a sketch of the graph. So it's 2 minus x squared. So this one here is going to look like this. It's going to go up to, it doesn't have to be a perfect graph, but it's going to look something like this, 2 minus x squared. Okay, so for this, it says, what are the shapes of the cross sections? Every cross section perpendicular to the y-axis is a square. Okay, so that means the square is going to be perpendicular to the y-axis. It's not going to look like a square, but it's coming off the graph. So this is in 3 dimensions. So you have infinitely many squares here. And we're going to integrate along the y-axis. Okay, so for this one, the area of a square is going to be s squared. So we need an expression to represent s, the side length of each square. Well, if this right here is x, wouldn't the side length of the square be double that? Does everyone see that? Or let's see, give me a second here. S is x. Hold on one second. So it's 2 minus x squared. Side length. Let me read this again. Oh, it's only in first quadrant. I didn't see that. Okay, so this makes more sense now. So first quadrant, sorry. So I am going to redraw my squares. So we're only working in quadrant 1 here. Okay, so if we're only in quadrant 1, it's going to go like this and like this. So the side length of each square is just going to be the x coordinate of the parabola. So I can write my area of each square. It's going to be, well, let's take the equation y equals 2 minus x squared. I'm going to solve for x squared here. So x squared is going to equal 2 minus y. And then I know that s is equal to x. So that means I can say that s squared equals 2 minus y. So I can take this and plug it in for s squared. So the area of each squared is just 2 minus y. So when I'm writing my integral, I have infinitely many squares where I'm going from y equals 0 up till y equals 2. That's going to be the y coordinate of the vertex. So we're going from y equals 0 up to y equals 2. And then for my s for the area, you're just going to add up the area of each cross section, which is 2 minus y. This is with respect to y. So my answer for number 87 is B. So make sure you read the question carefully. I did not do that the first time. I missed where it said quadrant 1 or the first quadrant. So that's going to give me the volume that's created this shape here. So this creates a three-dimensional figure. And we're finding that volume created by infinitely many squares from y equals 0 to y equals 2, going up the parabola. Is that okay for 87? Okay, any other questions?